Question number 1 of the PhilNITS FE morning portion of the exam. In this question, we are being asked, what is the decimal representation of the hexadecimal number 123.4? This question is one of the most difficult ones, I think, in the exam. And if you're also one of those guys who may want to skip this question, I think it would be wise to do so and look at the other remaining questions and then return to this once you've done the others. Still, if you would want to try it out, I think eventually, if you have enough time, you can solve this question like I did. I did find the correct answer, which is letter C, although to get there, I had to try out quite a number of the things that would lead me to the correct path. The way I did this was first to look at what we're dealing with. Our input is saying that we got 123.4 and it's supposed to be a hexadecimal number, and our goal is to convert it into a decimal number because it's asking us what is its decimal representation. The way I first tried to solve this problem was to see if we can divide this by 16, because we know if it's a hexadecimal number, there would be 16 possibilities, and I thought that maybe that would give us the decimal number. But if we did the math, we gotta use the long division in this case because we're not supposed to use any calculator at all, nor check anything online. And I thought that, okay, let's see if we can divide this by 16. And if you can remember how to do that, we put 123.4 here inside this division symbol, and then outside we got 16. Okay, now again, just to remind us how to do this, 123, we don't go there right away. We start off first with the first digit, and here we say that 1 is too low or less than 16, and we need another digit. That's why we need to add 2 here, but it's still less than 16, and therefore we need to go to the third digit. That's why we get 123. Now we say that 123 is already greater than 16 and want to know how many 16s are there in 123. And eventually, if you think about it, you come up with 7, and 7 times 16 would give us 112. And then we have to subtract these two. That's why we'd get 1 here and then 1 here again. And the next question would be, how many 16s are there in 11? The thing is, it's too low. It's less than 16, so we need another digit. That's where the 4 comes in. Remember that we're already going past the decimal point. That's why we have to put the decimal point here as well. And therefore, 114 is greater than 16. So how many 16s are there in 114? We remember our answer a while ago, 112 with 7. And so we put 7 here as well, and we put 112 here because 7 times 16 is 112, and we have a 2 afterwards after subtraction. But really, if you look at 7.7, you don't see that in any of the choices. So it looks like this is a wrong path to take, but something that we did, and because of that we know that it's already wrong. We gotta look for another way to solve it, right? So how do we go about arriving at 191.25 in this case, if that's the correct answer, or whichever answer, because we don't really have a clue yet which could it be, right? Now what I did was to see what I remember with binary, because I think binary would be somehow easier to do, because it's something that it's a lot used, I guess, when doing any of the problems that come out in the exam and in any of the other exams, more than the hexadecimal, I think. But in this case, we got a question with something related to the hexadecimal. Therefore, let's start off first with what we know. And binary, if we remember well, is something like this, where if our input is 1011, the way to count this and convert it to decimal, to a decimal number, is to do something like this, where the first digit rightmost would have the value of 1 if it's 1, and then going to the left we do something like 2 4 8. How did we do that? Because we're talking about binary, that means that there are two possibilities per digit, and if it's the first digit, if it's 1, then we have to put 1 here. Because if we start at 2 first, for example, this is 2 first, we won't get the whole decimal number. If, for example, what we want is 3. If we start at 2 here, the next is 4, how do you get 3? So we got to have the first digit 1 if it's 1. If it's 0, then this is 0, right? Now the next one, we move into 2, okay? So therefore, if this is 1 1, what we'll get would be 2 plus 1, which is 3, okay? In that way, we can count all the numbers in decimal form, all right? And again, it's about the possibility of having 1 or 0. And so therefore, if the next digit is 0, we don't add that in our count. Although in this case, if we just want to remind ourselves what would happen if this were 1, then it would have the value of 4, okay? Now the last digit here, the leftmost, would have a value of 8 if it's 1, okay? And in that way, our computation would be 1 plus 2 plus 8, okay? 4 we don't count because it's 0. Now if this were 0, what we'll do is 2 plus 8 only, okay? And in that way, we can get the decimal equivalent of the binary number, all right? Now how did we do 2 and then 4 and then 8 right away? We have to remember something about 2 to the 0, anything raised to 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. Okay? So that is the pattern, the rule that we should remember. Although I think in my case, I just quickly did 1, 2, 4, 8, something like that. Which I think is something that we'll also use in the hexadecimal. But in my case, I guess I had to try out more to arrive with this answer. But the idea that each of the digits would have the possibility of, in binary, 1 or 0, and in this case any of the 16 available digits or letters for the hexadecimal number. Now, okay, so this one, 1, 2, 3.4. Actually, I didn't know how to deal with the dot 4. So I just went with what I knew again. And in this case, using the pattern that we use for binary, maybe we can use the same thing with this one. So I did 1 and then 16 because we know that there are 16 possibilities. And again, there's 1 here because we want to count the whole set of the decimal numbers, right? Because if we started first with 16 here, like in this one, we started first at 2, we won't get 1. We won't get 3. also. Okay, and later on the explanation really is um, 2 raised to the 0 is 1, and then 2 raised to the 2, 2 raised to the 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, right? So in this case, the same way, 16 raised to 0 is 1, 16 raised to 1 is 16, 16 raised to 2 is 256. How do we know 16 raised to 2 is 256? We did the math. 16 raised to 2 is 16 times 16, right? And we need to do the long multiplication because we don't have access to the calculator nor any of the websites online. So we do this like this. 16 times 16 is, in this case, 6 times 6 is 36. Okay, let me see if I can get this much larger. Okay, and then let's see, 6 times 1 plus 3 is 9. Then 1 times 6 is 6, 1 times 1 is 1. Then we add them up, 6 goes here, 9 plus 6 is 5 here, and then 1 here, and that's why this is 2. Now, we now have 256 here, so how do we count it? And as it turns out, what we need to do is to multiply them with the digits like this, where 1 times 3, 16 times 2, and then 256 times 1. Okay? Again, if this were 0, then 1 times 0 is 0. Alright? And from there, we can add them all up. In this case, I did also the addition. Started off first with 32, which is 288. 2 plus 6, 8. 5 plus 3 is 8. Then 2 here. Then 3 plus 3, 291. And at this point, actually, I'm just trying out how to get one answer or something that looks like an answer. And when I arrived at this one, just trying out whether I could find something, I looked at the choices and I saw that there's 291 here. The problem is there's this other part which I wasn't really too sure too how to solve because it's after the decimal point. So how to solve it? What I did was think about the idea that if we have 16 possibilities and the number is currently at 4, how would we convert that into a decimal number? And I thought that, so if, for example, we want to know what is the equivalent of that in fraction, 4 divided by 16 would be done in this way, right? And we're asking how many 16s are there in 4. And what we get is that, remember, the input is 123.4, right? And we want to know how many 16s are there in 4. What we get is, well, 4 is too low. It's less than 16. We need another digit. And that's where we got the 0 here. But we need to put a decimal point here. And so when we get 40, we want to then again ask how many 16s are there in 40. And we say there are 2 16s there. And 2 times 16 is 32. Multiply 2 by 16 gets us 32. And then subtract 40 and 32. That's why 40 minus 32 gives us 8. And we can get another 0. And from there, I think that we should arrive with dot 25 if we multiply 5 and 16, because 5 times 16 is 80. All right, and from there we can arrive with dot 25. Um, I think that that part is something that I need to also think about some more. And it wasn't like with the first part here that we just do 116, 256, because this one needed to have another type of thinking that shows that we understand what is 16, what is a hexadecimal digit in this case, right? We know that this is a set of possibilities. It could be a number or letter, and it's saying that in this case, the hexadecimal number is saying that it's 4, and from there, if we think about how we would get the percentile of the number in relation to the total, which is 16, I think that led me to arriving at dot 25. The other possibility was 5, but dot 25 seemed okay already, and so the correct answer is letter C, which is what I eventually chose.